All right, here we go. Question number 50 from our Calculus 1, homework number 1 in WebAssign. It says, find the largest number delta such that if the absolute value of x minus 1 is less than delta, then the absolute value of 5x minus 5 will be less than epsilon, where epsilon is 0.5 first, and then we're going to repeat the process and make epsilon smaller, 0.05. And so what I want to do first is I want to bring up the precise definition of the limit. We know that the limit as x approaches a of f of x is L. If and only if, given an epsilon greater than 0, there exists a delta greater than 0 such that if the distance from x to a is less than delta, then the distance from f of x to L will be less than epsilon. I want to show how we can take this and extrapolate the information we need to solve this numerical problem. So back over here, we can see that x minus 1 is less than delta. So if I go back here to my definition and replace this absolute value to say x minus 1 less than delta, then what I can do is I can see that negative a is negative 1. So this is going to tell me that a is 1. That's one of the pieces I need. And back here, it says then the absolute value of 5x minus 5 less than epsilon. And so I can come over here and plug that in. The absolute value of 5x minus 5 less than epsilon, that's going to tell me two things, that f of x is 5x and that L is 5. And so now let's make some notes. So here's what we know. We know that our function f of x is 5x. We know the limit of the function is 5. A is the number that we're approaching. We're approaching A. And epsilon is the tolerance or the amount that we're allowed to deviate from L. So I've drawn a picture here to kind of represent what's going on. And to make a couple of notes, the limit here, this is 5. We got that from our problem. A, we know, is 1. And if I simply do direct substitution into the function, 1 times 5 is 5, we can see that is the limit. But we need to answer this question about what does delta need to be so that we stay within this tolerance of L. So let's figure that out. This would be epsilon. Remember, that's the amount that you're allowed to deviate on either side of your limit. And so making a note here, that upper limit is going to be 5 plus 0.5 or 5.5. And then the lower limit is going to be 5 minus 0.5 or 4.5. So those are the y values that create our epsilon buffer around L. And then if we scroll over and down, and over and down, then this would represent our x1 and our x2, which we can then use that to calculate these distances that are delta. Remember, these are the amount that you're allowed to deviate from A so that we stay within epsilon of L. So using the visual representation to try to make the calculations make sense, here I know that my y's that are surrounding our limit, remember the boundary based on epsilon, gave me an upper bound of 5.5 and a lower bound of 4.5. We can then use those values, plugging those in for f of x to calculate the x's. And so we're going to say 4.5 is 5x. And then we're going to say 5.5 is 5x. And then we're going to solve each one of those equations for x. and that will give me my x1 and my x2. And using my handy dandy calculator, we've got 4.5. We're going to have to divide by 5 on both sides, and that's going to give us a decimal value of 0.9. And again, if I divide both sides by 5, that's going to give us 5.5 divided by 5, giving us a decimal value of 1.1. Now that we know our upper and lower limit for x, we can calculate our delta. Remember, delta is the amount that we're allowed to deviate from a. So we need to do subtraction, starting with 1 minus 0.9 would give us 0.1. That is our first option for delta. And then to find the distance that 1.1 is from 1, we would actually subtract 1.1 minus 1, again giving us 0.1. And since those values are identical, then you don't have to necessarily pick the smaller one. They're both the same value. And so that means that our delta needs to be less than or equal to 0.1 in order for our y values to be within 0.5 of our limit. And to answer the second part of this problem, all of the work is going to be repeated with 0.05 as our epsilon. So here the only thing that's going to change, epsilon is now 0.05, which means that our y values are now only 0.05 away from our limit. So that would be 5.05 as the upper limit, and then 4.95 would be 0.05 lower than 5. And changing these values in our calculation, 4.95 and 5.05, that's going to give us different x's here. Here we go, 4.95 divided by 5 as a decimal, 0.99, 0.99, and then 5.05 divided by 5, 1.01. And again, with these calculations now, this is 1 minus 0.99, which is going to give us a delta of 0.01. And can you guess this one's going to be the same? Because now we're changing this to 1.01. Minus 1 is just going to leave us 0.01. Again, since these are identical, neither one is smaller than the other. And so that would give us our delta for this second situation. And then of course we need to click submit and see how we did. And getting the green check mark of success means that we're done with the problem. So if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.